Greetings of the day, dear students. In this video, we are going to discuss about the construction of three-phase synchronous motor. We will see its diagram and what are the different components present in a synchronous motor, right? So here, if you observe, now the synchronous motor is almost electrically identical with an alternator, which is nothing but a synchronous generator, right? The same synchronous machine, if it is driven mechanically and if the output is electrical, right, then we will call it as a synchronous alternator or generator. The same synchronous machine, if the input is electrical and the output is mechanical, we will call it as a synchronous motor, right? Just like same as in the case of our DC machines, where we are having DC motor and DC generator. The main essential components will be, here also we used to have a stator frame, right, and also we used to have a rotor, and this stator is going to have the slots. In the stator frame is going to consist of the slots where we used to place the stator winding, right, and this stator frame will be laminated, and this is made up of using silicon steel, and which will be laminated in order to minimize the hysteresis and eddy current losses. That a core will be laminated. The core will be laminated. Similarly, here this rotor, we will be having the alternatively the north and south poles will be there, and which will be having a number of alternating north and south poles, and the field winding will be placed in the rotor slots. And obviously the winding that is placed in these rotor slots will be excited with the help of some small DC shunt generator. Because of that, some magnetization of the poles will happen. In some cases, in some machines, there will also be the permanent magnets, right? So here, now this rotor can be of either salient pole type or smooth cylindrical type. These are the two possibilities we are having. It can be of either salient pole type or smooth cylindrical type rotor we will be having, right? So this is about the construction of three-phase synchronous motor. If you can observe in the diagram, this is the rotor, stator frame, and windings will be placed in these slots, and three-phase supply, electrical supply, three-phase supply will be given to the stator frame. So depending upon the number of poles, magnetic poles, number of poles that will present in the rotor, correspondingly to that the three-phase winding will be wound, right? And because of the given electrical supply, revolving or rotating magnetic field will be established. And now if this rotor rotates at the synchronous speed, then it experiences some torque, because already the rotating field, revolving or rotating magnetic field will be there, and this rotor which is having the alternating north and south poles will be coming under the rotating magnetic field, right? Will be coming under the rotating magnetic field, and if it is going to experience the torque. Based on that, the rotor will be set into the motion. And some key points are, you can observe here. Here some characteristic features of the synchronous motor will be, the synchronous motor will run either at the synchronous speed or will not run at all. The only way to change its speed is to change its supply frequency, which is nothing but Ns equals to 120 F by P, where F indicates the frequency of the supply, P indicates the number of poles. And one more point is the synchronous motors are not self-starting, and they need some external force to bring them nearer to the synchronous speed. Then only it will get operated. And they can also operate under any power factor, lagging as well as leading. So hence synchronous motors can also be used to improve the power factor. For power factor improvement purpose also we can use this synchronous motor, right? This is how the synchronous speed. This is all not required here, just construction wise this is enough. In exam point of view, This is the stator frame, 3-phase winding, rotor, and north pole, south poles, alternating north and south poles. Right, the rotor types are salient pole type or smooth cylindrical type, and the stator frame will be having the laminations, which is made up of silicon steel laminations, and it is laminated in order to minimize the hysteresis and eddy current losses. Right, thank you.